Hello, everyone. My name is Hyungchai Park, as Professor Gong introduced. So I work for the Stanford Center at the Incheon Global Campus as a research director of mobility. So actually, my collarbone was broken last uh, Tuesday, and I got surgery on Thursday. So that's why I got this one. So yeah, please bear with me. But it doesn't affect my presentation today. So the title of my presentation is On the Road to Smart Mobility. So where are we? So the title sounds very heavy because the mobility is a pretty huge subject. So definitely I can't cover everything on it. So I only know a fraction of it. So in my presentation today, so I'll focus on a car, the most important components of mobility, and also people's effort to make it better and safer. And after that, so I'll surely talk about smart mobility, how we achieve smart mobility and what kind of smart mobility we want. So I'll start with okay, check. So I'll start with the passive safety system. So which protect passengers inside the vehicle. So when and after an accident happens. So the development of also the, for example, seatbelts and the airbag and better chassis designs are included in this category. And the development of the passive safety systems for the last 50 years is very well summarized in this crash test video. So this crash test was conducted to celebrate 50th anniversary of IIHS, which means Insurance Institute for Highway Safety in the US. And in this crash test, so the 1959 Chevy Bel Air and 2009 Chevy Malibu was collided head-on, front to front, with 50% overlap, which impact a driver very heavily. So as you can see, the both cars are damaged very heavily outside. But now you can see what happens inside of a car, surely. Actually, there should be a sound. So inside of the 1959 Chevy Bel Air, so you can see that there's no airbag and probably no seatbelt too. And the movement of dummy is not well controlled. But in case of the 2009 Chevy Malibu, now you can see that the airbag will be deployed and the movement of the dummy is pretty well controlled. And this picture shows the outcome of the crash test very well. So the left side is the 1959 Chevy Bel Air. So as you can see, the engine pushes it backward to the cabin. So it damages the dummy very heavily. But on the right side picture, so if you don't care this side and the airbag, it almost like there seems no accident. So the Malibu driver would have been okay and with minor injuries. So he might just walk away right after the accident. So how this kind of developments is possible? So all developments are thanks to your senior engineers' blood, sweat, and tears. And now I'll talk about active safety system. So before to talk about active safety systems, so we need some understanding of vehicle dynamics. So my question is that, so what makes a car move? So the car weighs at least more than 1 ton. It's a very heavy object. And then what makes a car move? Anyone want to try? Could you say Ralph? Yeah. So if you see a vehicle as a closed system, and all forces and moments, to mainly move a car comes from tire patches. These 4 tire patches, which is the area that tire contacts the roads. So the size of the contact patch is about the size of your palm. So what happens in this small area determines the whole vehicle dynamics. So by knowing this fact, so you just master the vehicle dynamics. Then what is the active safety system? So the active safety system is the continuously monitor vehicle stage, like speed or the yaw rate. And if it detects some instability of those states, then it tries to modulate tire forces to bring a car back to the stable region. So one of the very famous active safety system is electronic stability control, ESC. So also the effectiveness of ESC can be well shown in this video. So in this video, an SUV is trying to make a lane change on a red road. So at the top without ESC and at the bottom with ESC. Oh.
The benefits of ESC are clear. If every vehicle on the road had ESC.
So even though those 2 cars are trying to make a same movement, but the outcome is very different. So, but in case of the without ESC, if the other cars are moved forward in this direction, and there should be the second accident. So effectiveness of ESC also can be verified by several papers. So one paper says that ESC can reduce a single vehicle crashes of cars by 32%. So in terms of some engineering sense, some adoption of some system helps something in more than 10% is a huge thing. So the 32% is a very meaningful number. But both passive safety systems and active safety systems only cares about a single car. So it cares about the passengers inside the car. So like a rally driving. So rally drivers only care about what is happening on my car. But actually, when you drive on a road, so you are not alone. So there are lots of other components on the road, like other vehicles, other motorcyclists and pedestrians and some traffic signs, lanes, crosswalk. So but thanks to the development of some sensing technologies, so now cars can recognize environments, this environment, something around the car. So those sensors that makes a car recognize environments are radar and camera. So the first commercial radar was introduced by Mercedes-Benz in 1998 or 99. It's a 76 gigahertz automotive radar for passenger cars. And radar can detect so the location of the front object and also the speed of the front object. And the camera system, so the first commercial camera system was vision system was introduced by Mobileye. So if you are interested in autonomous driving industry or if you are interested in stocks, then you might be heard of the name of the company. So the Mobileye introduced the IQ1, their first model, production model, in 2008. So by analyzing the image from camera, so they can give a lot of a rich semantic information, like where is the lane and where is your cars and or where is your pedestrian or something like that. So by combining information from these two sensors, so now we can implement more advanced driver assistance system, so which is called ADAS. So is there anyone drive your own cars? Yeah, so then your cars might have these systems. So for example, adaptive cruise control, emergency braking, and collision avoidance, and park assist, surround view monitoring, those kind of stuff. So which makes the driving test much more easier than without these functionalities. So one of the functionalities of ADAS is AEB, autonomous emergency braking. So this system keep monitoring the environment, and if it detects some imminent collision, but a human driver doesn't brake it at all or doesn't brake enough, then the system intervenes and applies the full braking to mitigate the impact of the collision. So the importance of AEB is importance of AEB is that so when a new car is released and those cars are assessed by a new car assessment protocol, which is operated by the NCAP. So the most famous NCAP is Euro NCAP. So now Euro NCAP starts to increase the portion of these active safety systems. So if you get the more scores on these active safety systems, your car has a more higher safety rating. So you might have seen the 5-star safety rating or something like that in the advertisement of the cars. So in the marketing standpoint, it is very important to say that our cars are safe. So the car makers are trying to make these systems better and better. And also the test protocol of these systems are getting more complex every year. So this video shows how AAB is assessed by the Euro NCAP. So clearly we cannot test this system with a real human. So there is a moving dummy. So we test day and night. So it failed. And also not on a straight road at an intersection too. And even with a bicyclist, which is faster than pedestrian. And at the last protocol, so by parking the two cars and making a bicyclist move behind those cars, so it intentionally blocks the perception of the bicyclist. So that test protocol want to see that how quickly the AAB can catch up those moving bicyclists. So when you think about AAB again, so this system make a decision by itself and make some actions also by itself. So which probably reminds you autonomous driving. So first check the brief history of autonomous driving. So even in 1980s or in 90s, there was a lot of projects to make highway autonomous driving possible. But The autonomous driving that we know today starts in 2004 through DARPA challenge. So the DARPA is the abbreviation of the Defense Advanced Research Project Agency, led by U.S. Department of Defense. So they want to develop some military technology using autonomous driving. So in 2004 and 5, uh, so the competition was held off-road, and in 2007 in a city. So it's a competition uh, for the fastest autonomous driving cars that moves from point A to B. And the technologies and people uh, who attended these competitions became basis, uh, became the basis of the modern autonomous driving. So in 2010, Google declared that, so we will start autonomous driving technology development. And then lots of other startups and big techs and the traditional automakers followed up the movement of Google. And in the middle of 2010, and the people also think about the business model. So to make money using autonomous driving technologies, for example, robotaxi or delivery. But when you think about the autonomous driving technology, so and you compare that technology with the technology that bring a human being to the moon. So which sounds more realistic? So personally, so the bring person to the moon is sound unrealistic, but uh, for some reason we think that autonomous driving is very natural to us, even though we already sent a person to the moon, but autonomous driving is not fully implemented yet. But still, autonomous driving is very familiar to human beings. So personally, I think it's because we already have a transportation mode that enables autonomous driving, so which is a horse. So the well-trained horse can bring a person from point A to B without the specific directions. So that's why we are very. So the human being might have a DNA that makes people feel comfortable with autonomous driving. So SAE, so Society of Automotive Engineers, defines the levels of driving automation in 6 levels. And you don't need to know the specific definitions of each level. So we can also divide these levels into 2 parts. So the up to level 3, so it assumes human interventions anyway. But from level 4, it's a full autonomous driving technologies. Then what kind of technology we need to implement autonomous driving? So naturally, so all functionalities you need when you drive, actually we need all those functionalities. So when you drive, you first sense the environment using all your senses, for example, the eyes, ears, and hands, even through your body. And after collecting the information from all your senses, you form a complete scene or full understanding of your environment. And when you drive, you are moving from point A to B, so you must have a sense the whole path from point A to B and where I am now. And once recognizing the where I am, so I have to decide my behavior to get to the point B. And then I have to plan my motion and actually to control my car to follow that motion. So when we drive, we follow these procedures, and definitely the autonomous driving cars also needs all functionalities in each process. So first we need sensor to sense the environment, and we need a sensor fusion to make one complete scene or understanding of an environment. And then we need a map and localization. So we need the understanding of the path from point A to B and the where we are along the path. And then we have to develop behavior measure. So at the current position, so what we have to do to get to the point B. So for example, we can go straight or turn left, turn right, make a U-turn, make a lane change. And to achieve those behavior, we have to plan our motion. So for example, when you make a left turn, so you have to think about your path and your speed. And once you plan your motion, then you control your steering wheel and brake pedal and acceleration pedal to follow that motion. So we need all these 6 components to fully implement autonomous driving. So in level 4, so each technology stack should be the state of art. But in level 3, so even though we need all those stacks, but the technology completeness of these technology stack should not be, don't need to be the super completed. But in level 1 and level 2, even we don't need the map and localization and motion planning parts. So this sounds very natural and simple, but until 2010, so we cannot actually implement the components, these technological components. But thanks to some technological breakthroughs, now we can implement this system relatively easily. So one technical breakthrough is vision analysis by deep learning neural networks. So this video was made at around 2022. Oh no, 2020. So when I worked for the Phantom AI, my previous company. So the main business model of Phantom AI is to develop a vision analysis system, vision analysis software for ADAS systems. So we installed total 8 cameras all around the vehicle, and then we analyzed the environment using deep learning neural networks. So as you can see, the purple areas means drivable area, and orange or the orange colors means the lanes, road range, and the boxes, 2D boxes in cyan color means the detected vehicles. So, and by collecting all those information, we can create the bird eye view, which shows the situation all around our ego vehicle. So let's see this video. And we can do this analyze real time, thanks to the development of the technology. And this video shows what Tesla's neural networks see. And actually, this video is also released about several years ago. So the most recent Tesla's neural networks will become much more clever than this video. So in this video, as you can see road lanes and the stop signs, the cars in front of me. So in a very complex urban situation, so it can detect the 3D bounding box, so which is very helpful to estimate the pose of the vehicle very accurately. You can also check the traffic sign, stop sign, crosswalk. So yeah, it gives only through vision analysis, it gives very rich semantic information. And the other technological breakthrough that makes autonomous driving possible is LiDAR. So LiDAR is the abbreviation of light detection and ranging. So while radar is using the electromagnetic pulse or radio wave, so which gives low resolution information about about an object. So LiDAR is using laser light, which gives very dense point cloud information about an object, also very accurate uh, distance information. So which is not possible in vision analysis through camera images. So even though the price of LiDAR is getting lower and lower, but if you can see this picture just in terms of cost, you can see the Velodyne LiDAR sensor at the top of the vehicle. So when you see this picture, you can think of this picture as there's one more car on the top of the car, because at that time the price of one sensor is about $70,000. So which probably may exceed the price of a car itself. So LiDAR information is used to detect object, but the main application of LiDAR in the modern autonomous driving technology is the localization. So in this picture, so the green dot and white dots are high definition map. So autonomous driving vehicle scanned the area with LiDAR in advance, and they create the HD map. So the green dots is the something above the ground, and white dots is road markings. And those red dots is a real-time LiDAR measurements, and the red point is the estimated vehicle pose after localizing the position of the vehicle through the LiDAR information. And the blue point is a location of vehicle only reported by GPS. So when you see this video, let's focus on the difference between these 2 points. So the 2 different positions, one is reported by the localization using LiDAR, and one is reported by only GPS. So while car is moving, so the real-time LiDAR measurements is keep changing. So they compare real-time LiDAR measurement with the existing HD map. So from those comparison, so it decides the exact location and pose of the vehicle. So as you can see this picture, so the difference between these two two locations is almost width of one lane. So if you make some decision only based on the GPS location, and it might result a very critical accident. And vision analysis through the deep learning and also this localization using LiDAR requires lots of computing power. But CPU-based computing platform or GPU-based computing platform turns out to be very effective to calculate those calculations real time. And that's why, so now NVIDIA, formerly a graphic card manufacturer, now becomes a leading big tech company in autonomous driving industry. So thanks to the developments of these technologies that actually make autonomous driving possible, and also the people's interest in autonomous driving, and investors says, take my money. So Silicon Valley becomes the very great place to do something related to autonomous driving. So this map shows how many companies are located in Silicon Valley only related to something automotive industry. So traditionally in the US, the main location of automotive industry is Detroit. But now, as the autonomous driving is emerging, now the Silicon Valley becomes a new center of the automotive industry. So there are lots of companies, and some companies are developing autonomous vehicle full stack. So they are doing from A to Z everything about autonomous driving. So you might be heard of Jukes here, and Waymo here, and Pony.ai, and yeah, etc. But it's very hard to do everything in-house. So because of that, some companies are focusing on a single uh, technology stack, for example, HD map or sensor hardware. So you might be heard of Oster, LiDAR company, and Lumina, also LiDAR company. And some companies are focusing on the perception software development. So the Phantom AI was located right behind the SFO, San Francisco Airport. So from 2010, so the autonomous driving industry has been prospering, was booming. So you might be heard of some tech leaders talk about the commercialization of autonomous driving in 2017. But actually, we are in 2017. So they are saying that, oh, so we're commercializing autonomous driving in 2019. But in 2019, they are saying that, oh, in 2020. But these days, no one says those kind of positive statements about autonomous driving commercialization. And the why this happens. So let's think about what kinds of hurdles of autonomous driving we have. The first, unit cost. So if you, for example, it's just an example. So if your Elantra has the autonomous driving technologies, but the price of that car is about 100 million won, which is 1억, I'm gonna buy it. Because the components used in autonomous driving cars are still very expensive, even though the components, the unit price is getting lower and lower, but it's still very expensive. And durability and warranty. So we assume that the car should drive in any situation, especially in Korea, very hot weather or cold weather, rainy season. But we're not sure these high-tech components are surviving those harsh conditions for several years. And safety and reliability. So if we have some understanding of the deep learning networks, can you say that 100% of the correctness of the result from the deep learning neural networks? And also ethnic issues, insurance. So the autonomous driving commercialization is not just about technology. So because driving itself is a kind of social contract. So we have to bring autonomous driving into our society, which requires the social consensus. So you might be heard about some trolley dilemma. So for example, autonomous driving cars should collide with something anyway. So the only two options are car or pedestrian. Then autonomous driving cars should make what kind of choices? So it's a very hard question. So it's also related to some technology, but it's mainly concerns of ethnic components and insurance. So if an accident happens, so who is responsible for that accident? So the autonomous driving car makers or a driver inside the vehicle, even though he or she doesn't drive. So yeah, it's a hard problem. And no matter how well you designed your system, it operates in real world. So it can encounter any unexpected situations that the engineers haven't thought about before. And also, yeah, don't think about anything state I mentioned previously. Just think about autonomous driving in terms of software implementation. So these numbers show the lines of code they require to complete each project. So the Apollo 11 project requires 155,000 lines, but the autonomous self-driving cars, people say that it requires 300 million lines of code. So that's why the bring a person to the moon may be much easier than the self-driving car implementation. That's why. So can you guarantee there should can you guarantee there should be no bugs on the 300 million lines of code? So each module is written by different people, and yeah, it's in software. In terms of software implementation, it's a level of hell difficulty. Yeah. And also, even we haven't reached a consensus how to implement autonomous driving. So there is some debates between two groups. So one group, or actually one company, insists that so we can implement autonomous driving just using the camera. Uh, and the other group, and most of other companies, insist that no, we need some additional sensors like a LiDAR or NS radar. So in 2019, so only one company is a Tesla. And in 2019, Elon Musk said that anyone relying on LiDAR is doomed. But in this statement, he just mentioned about the cost because LiDAR was very expensive at the time. But the tweet probably last year in February. So he touches a philosophy of driving. So I will read his tweet literally. So the road system was designed to work with biological neural nets, which is your brain, and the eyes. So a general solution to self-driving necessarily will require silicon neural nets, GPU-based computing platform, and cameras. So he insists that because human can do the autonomous driving cars, which has a similar system, should also can do. So that's his statement. But the Volkswagen, traditional automakers CEO, says that we need some redundant perception to the 360 camera because these traditional automakers cares about safety or worries about the road shoot a lot. So they want to have some redundancy to uh, to guarantee the safety of the autonomous driving. So anyone have seen the Tesla's AI Day event video on YouTube? So only by hearing what I said about the camera vs LiDAR debate. So do you think that the camera only autonomous driving will be possible? Please raise your hand if you think that it's possible. Or we need some additional sensor except camera. Would you raise your hand if you agree? So anyway, but if you look at a video on YouTube on the Tesla's AI Day event, so they explain why they think that the camera-only autonomous driving is possible. So this is a diagram of the general deep learning neural networks. So we start with a small set of training data, and then when we do some tests, we expect that the trained neural nets gives us some correct inferred result. But the main disadvantage of this neural net is that, so if the input is a very rare case, which is not included in training data, then we cannot guarantee the result of this inference. So whether it may give us some garbage values, then if this happens in a car, then it directly relates to the cost of human lives. So that's the main criticism and also disadvantage of the using deep learning neural networks on autonomous driving. But Elon Musk and the Tesla engineers says that, so we will cover up this problem. So by putting the enormous training data. So through the OTA, over-the-air updates or something like that of the Tesla. So Tesla is collecting the huge size of the video data from their all customers. So it means that they have collected the enormous training data, which might cover the most of the corner cases that other car makers may don't have. So they think that by increasing the size of this training data set, so they might achieve the camera-only autonomous driving. So, but I think this level is kind of the human beings have never reached it. So I don't know the answer, and I'm very curious about what's the final outcome of their approach. So because of these hurdles and difficulties of the autonomous driving, so until 2020, autonomous driving industry was very prospering and booming, but now is a little bit reorganized. So some big companies are acquired by some big techs, which has lots of money. So Mobileye by Intel, Cruise by GM, Autonomy by Aptiv, the very big tier one automotive parts supplier, and Drive.ai by Apple, and Jukes by Amazon. Because the problems I mentioned previously, to solve these problems, even though the autonomous driving sounds very cool and high tech, but to solve the problems that autonomous driving has now, we need a very labor intensive approaches because we need more labor data, which requires human efforts. And also we need to verify the autonomous driving systems, which requires human drivers. And so those labor intensive approaches requires money. So these startups can't support those can't support anymore by themselves. So that's why those companies are acquired by some big companies that has a capability of supporting the money to complete the autonomous driving technologies. And some companies has failed. So I think I mainly talked about the dark side of the autonomous driving, but there is a bright side too. So even though autonomous driving technology has not fully completed yet, but still some companies are trying to find active business models that can make money using autonomous driving technologies. So the most famous one is robotaxi. So Waymo, Cruise, they are actually doing provide robotaxi service in San Francisco, and Jukes too, and Uber actually left the robotaxi industry, Lyft, and autonomous shuttle. So robotaxi is should cope with some general driving situations, but in case of the shuttle, so it drives along the predefined path, so which is the more controlled situation, which drive around the more controlled areas. So which is which means that the technology difficulty is lower than general autonomous driving. So autonomous shuttle might be some easy way to commercialize autonomous driving. And actually the autonomous trucking. So how many percentage of logistics is done by trucking in the US? Can you guess the number? Yeah, say any number. Yeah, you can guess. So almost 70% of the goods transport in the country, in the US, are carried around by trucks from one state to the other. And the trucking industry suffers their driver. The number of drivers are decreasing. So they have to find some solution anyway. So because of that, some people says that if autonomous driving is commercialized, then it will come first at trucking industry. So until now, I talked about autonomous driving technologies, but even when I talk about autonomous driving technology, it only cares about a single vehicle. So all technologies are about how to move a car, how to move a single vehicle. But we are moving around the mobility system, so which all transportation modes and infrastructures are interconnected. So when you think about mobility in current cities, and when you think about the only moving components of the mobility system, so there's a private owned vehicles and taxis and human driven MOD, mobility on demands, like Uber or Lyft, which is not serviced in Korea, and mass transit, including bus and train, and shared services, including scooter and bicycle. I believe you guys are using a lot. And active travel modes such as walking and biking, etc. And there are citizens with various mobility needs. So by combining these various transportation modes, so each citizen are moving around the city to satisfy their mobility needs. So for example, so the people was successful to build a mobility system that is kind of working, because when you think about when you plan a meeting with someone else, and when someone says that, oh, I cannot make that meeting because I can't go there, so then you think that that excuse is reasonable to you? Probably not, because these days, so there's nowhere that we cannot go. So which means that so each citizen can satisfy their mobility needs anyway. So, but the way to achieve that mobility needs is mainly by the quantitative increase of infrastructure. So this map shows the subway subway networks of Seoul, so which can carry 5.8 million people per day in 2020. And this shows the major roads in Seoul, which connects basically every single section of the Seoul. But even with very vast road and train subway networks, we still have a problem in our mobility system. For example, so no matter how many train lines are built, this will happen anyway. And when you think about the air pollution in 2016, so 57% of nitrogen oxide was produced in transportation parts. So we need some kind of solution anyway. So then what is smart mobility? So we want to achieve the most sustainable, safe, and efficient, affordable, and equitable, and etc. New mobility system that can solve the existing problems of the current mobility in cities. So we can achieve smart mobility through some ICT, information and communication technologies, and autonomous driving vehicles, and electric vertical takeoff and landing, eVTOL, for urban air mobility, or eco-friendly alternative energy sources like electric or fuel cell. So smart mobility is not something like a quantum jump. I think you guys already are a part of smart mobility. So by using the Kakao Mobility, a new platform. So actually the Kakao Mobility has changed our mobility life a lot. So uh, now you can call a taxi instead of just waiting outside of the road. And also thanks to the ICT technology, now you can check the status of the public transportation. So when I was young, so taking a bus is like a random process. So when I get to the bus station, I'm not sure whether my bus just came through or do I have to wait more 30 minutes more? So I don't know, but these days you can check the status of the transportation, public transportation very easily. So smart mobility is already in your hands in some extent. But you have to be cautious when you implement or to bring a new system into our mobility system to solve a problem. So can you recognize this picture? Do you think what is it? What kind of these small dots? Yeah, shared bike. So the shared bicycle is a very started with a good intention to solve uh, the mobility problems in a city, but some unregulated uh, adoption of shared bicycle actually resulted in this bunch of abandoned shared bicycle. So, which resulted in unexpected ending. So, because mobility is about a system, so all components are interconnected. So, just bringing one technology or one solution cannot solve the problem. So, to solve or achieve the smart mobility, then we need some systematic approaches and thinking uh, to find the optimal solution to the problems. But at the same time, you can be ambitious because the current mobility systems have reached their limits. So in terms of the pollution or in terms of society. So as I said, the number of drivers in public transportation and truck industry keep decreasing. But we we need to keep moving the people and goods through those logistics. Then we need to do something to cope with that situation. And also, as mobility becomes as a service, so it can create lots of new chances because autonomous driving make people uh, move from point A to B without driving by themselves, which means that they have more time. So there's a joke, or actually maybe the two statements, that Google started their autonomous driving technology development because to make people watch more YouTube while they are not driving. So believe it or not. And also by adopting these UAM technologies, it might change our mobility life fundamentally in the future. So I'd like to show that so what I have said is also talked about other people too. So one way to check it is that have you heard about the TechCrunch? So TechCrunch is online news media. Is mainly about uh, startups, technologies, and uh, investment. And actually, its premium membership in Korea is free because they have not established the payment system yet. So if you are interested in those areas, you can subscribe their premium membership for free now. So they are holding the session in each technology every year. So they held the mobility sessions in 2021. So and in these sessions, the agenda was self-driving delivery, autonomous driving truck, so which are the business models using autonomous driving technologies, robotaxi, electric vehicle, data for autonomous driving, eVTOL, micromobility, like a shared scooter or bicycle, and crowdsourcing mobility data and big OEM strategies for future mobility. In 2022, so the lots of topics are overlap, self-driving delivery and etc. And also they are interested in drone delivery and sensors or fleet management. Or so the people in this industry are talking about these topics. So if I have a few more minutes, I'd like to introduce our center. So our center is located in Songdo, and actually our center is just one of the many research centers on Stanford University. But the main difference is that so all other research centers are located on main campus, but our center, some portion of our center is located in Songdo in Korea. So it's the first try of the Stanford University. And the primary research topic of our center is how to implement smart city. But smart city is also a very huge subject, as huge as the mobility. So we cannot cover everything on it. So we choose the four research pillars, which starts from the vehicle and infrastructure systems and human urban interaction. So, and design thinking and entrepreneurship. And the last one is sustainability. So I'm mainly working on these two parts, the vehicle and infrastructure systems and human urban interaction. So in this area, we want to understand the current mobility systems through data. So we are closely working with the local government, Incheon Free Economic Zone Authority. So to get the public transportation data from infrastructure. And also we built a data collection platform. So in terms of hardware, it is autonomous driving ready. So by combining this infrastructure data and the data from our platform, so we believe that we will have a better understanding of the current mobility system. And we are also closely working with some private companies that has lots of mobility data. And our center has also a driving simulator because no matter how good new technologies are, so if people don't accept it, then they are users. So we quantitatively research on the public acceptance of new mobility technologies and systems. So this is the end of my presentation, and thank you for your attention. And if you have any question, please don't hesitate. Thank you.
한국어로 질문하겠습니다.
예.
네, 네, 감사합니다. 발표 잘 들었습니다. 그 자율주행 할 때 이제 카메라 라이다 말고도 레이더 센서도 얘기가 많이 되는데 혹시 레이더 센서에 대해서는 혹시 어떻게 생각하는지 여쭤보고 싶습니다.
Can I speak in Korean?
Up to you.
I think for radar sensor, I think Professor Kong is knows much better than me. So as I said, the traditional radar is using the radio wave, which gives a very low resolution information about the object. But these days, the imaging radar or the 3D radar is newly developed, which might give the similar level of information like LiDAR. So if we adopt those new radar technologies, then it might replace the existing LiDAR uh, or it can cover up the costs of camera image analysis. So I think radar technologies are newly emerging again right now. So I'm very positive about their technologies. Yeah.
Thank you very much.
Okay, thank you. Thank you for the presentation. But in your opinion, as a sake for the human being, is it really necessary to achieve the highest level of autonomous vehicles, the real autonomous vehicle, or there's like a state that this is enough for the human, not all need like really automated?
So I think it's a $1 million question. But when you think about a human driver, but definitely human driver is not perfect. But actually, we don't have any problem to drive on roads. So I think we have to achieve a social consensus. So how safe autonomous driving is acceptable to the society. So because we know that there is no 100%. So we have to set the kind of the limits or the the minimum requirements that we can say that, oh, if some autonomous driving technology achieve this level of requirements, then now we can say it's safe in terms of the social contract, and then we can bring that autonomous driving technology into our society, actually. So I think it's not just about technology developments, and I think it's deeply also related to some social consensus, I think.
Stanford Center also like research about the ethics and also some laws about the autonomous vehicles because it's like significant.
Yeah, actually, my academic advisor at Stanford University is interested in that problem very deeply. So actually, we held a symposium recently about 4 months ago about the law and ethical aspects of autonomous driving. So there is no very well-defined consensus about those areas yet. So we need still lots of discussions. Yeah. So if you are interested in, so I will upload the video from those symposiums to YouTube soon. So then you can check out those videos. Yeah.
아, 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 네. 일단은 선생님 내려와 주셔서 감사합니다. 일단 제가 좀 드는 궁금점이 일단은 저도 이 모빌리티 쪽을 공부를 하긴 하지만 지금 그 모빌리티 쪽에서 제일 좀 선단에 있는 그 연구자로서 좀 궁금한 게 있는데 보통 저희가 뭐 미래 뭐 교통이라고 하면은 마지막에 UAM을 띄우고 이게 미래라고 하잖아요. 근데 박사님께서 생각하셨을 때는 그 UAM이 진짜 그 미래 교통으로서 좀 이제 대안이 될 수 있는지 아니면 이제 박사님께서 생각하는 또 다른 생각이 있는지 좀 말씀해 주시면 감사하겠습니다.
I think there should be no general solution that can solve the mobility problems of every cities. I mean that, do you think the smart mobility in Daejeon should be the same to the smart mobility in Seoul? So probably not, because the situations of each cities are very different. So we might need different approaches or different solutions. So recently, I attended the DIFA forum, and one presenter said that so in their small cities, so he came from the Belgium or somewhere in Europe, and he said that in his small city, so the um, mobility on demand. I forgot the name of the service, but demand-based mobility was pretty successful. So, but I know that in Songdo, so Songdo has tried the similar thing, but the local government think that their trial for the same service in Songdo was not successful. Because so I asked him, so why do you think that those kind of differences happen? And he says that so in his cities, so the only transportation mode it's possible is by car. So there is only one solution. But in Songdo is a pretty big city, so it already has established public transportation networks already. So because of that difference, the same service was successful in one city, but was not in other city. So UAM, maybe I think we can apply the same approach to UAM. So in some specific situations, UAM will be very helpful to solve some problems, but it will not solve every problem, and it will not solve problems in some specific areas. But we can think of some situations, for example. So as I said, so if the number of taxi drivers are decreasing. So if there is no one to bring a person in rural areas, then in that situation, UAM might be the effective or maybe the only solution to solve the mobility problem. But in the big cities, not sure because there's a problem of what if accident happens, then what happened, for example, something like that. So in the big cities, I'm not sure, but in some special situations, we need them, I think.
감사합니다.
안녕하세요. 발표 감사드립니다. 제가 중간에 놓쳤을 수도 있는데, 마스 관련해서도 얘기가 나온 것 같아서, 혹시 자율주행 쪽으로 이제 웨이모 같은 택시들이 등장하게 되면은 그거랑 이제 결합해서 뭔가 상품이 나올 것 같기도 한데요. 그 관련해서 혹시 진행 중인 연구가 있으시면 어떤 것들을 주로 활발하게 연구를 하고 계신지 좀 궁금해서 질문 드렸습니다.
Sorry, I'm not an expert on Mars area, but actually, when you ride the Kakao taxi, so these days Kakao taxi has a small screen in front of the passenger, so it shows the advertisement. So it might be the one possible business model in Mars, or you can show some possible destination, possible visiting places at your location. So there might be the possible business model. So I think we just started the Mars, so there should be lots of possibilities and new chances will be there. So yeah, it's a pretty open areas yet. So yeah, maybe that's the area you might contribute to a lot. Yeah, in the future.
Okay. Hello.
I can hear you anyway.
Okay. Yeah. Okay. Thank you for your presentation. By the way, I just want to ask, like, if someday like autonomous vehicle have been the main transportation in the world, maybe in the big city like New York, and then but we know that like autonomous vehicle is operate mainly using the sensor get used is usually camera and radar, and sometimes lidar. But we know that radar and radar operates in some frequency. we know that they operate in some frequency that should not be interference with other frequency. But it will be a problem arise if there's a lot of car in some area, and then some of the frequency they use the same frequency or maybe a similar frequency. Because as long as I know, if like some frequency get is not very far enough interfere, they will they will make a lot of noise in the other sensor.
Yeah, I think it's your statement is very reasonable. So because we have not reached the level of the adoption level, the level of the 100% autonomous driving tech cars yet. So if all roads are full of the autonomous driving and all those vehicles are using lots of sensors and emitting the lots of radio waves, and yeah, it might cause that kind of problem. And also, some people worry about the LiDAR because because they keep emitting the laser around even though the power of those laser is pretty low, and the manufacturers say that it's safe, but the old cars has those the LiDAR equipment on the roof, then it might not sure the what effects will be what kind of impacts will be done in the human's eye. So we have to think about that. And also, some people are worrying about usually the electronic vehicles are heavier than the gasoline engine vehicle. And if all vehicles are replaced by the electric vehicle, then for example, parking structure should not sustain their weights properly because their original design should assume that the gasoline engine vehicle using the weight of the gasoline engine vehicle. So if those new technologies, the adoption level is increasing, that we might encounter some unexpected problems. So yeah, I think that your statement is reasonable. Yeah.
Okay, thank you for your answer.